Henry Howard. I'm coming live and direct to you from my own home, and I am here to do a video for my new channel. I call it Cisco Collaboration Hank LLC. This will be a channel that I'll be using to document my ongoing training to recertify as a CCNP and in the future, and one day get the CCIE collaboration and recertify every 3 years for that certification in voice telephony. And so what we're here to do today is we're going to share my quote-unquote CCNP or CCNP Gold CCIE training notebook that I have on my personal computer. I'm here to organize it because it has been hasn't been used it's been used off and on since 2010, but it's 2023, and I said it's time for me to document what I know so that I'm able to prepare for upcoming interview questions, but more than anything, I'm able to prepare for upcoming exams. So there are going to be a couple things that we're going to do today as we go through the organization or reorganization of our documentation. Why? Because there's always new things that come out every single day, and they require us to know stuff. But one of the things I learned when I was in college was Microsoft OneNote. And Microsoft OneNote has been a blessing to me because it's really impossible for anybody to technically have documentation in their heads. So we're going to be going up and down and reorganizing things, and I'm going to start off with, I think, the most important thing that I really want to organize will be my quote-unquote voice bootcamp little subfolders. And so we have tabs at the top, and then we have quote-unquote tabs on the right. I don't know if you've used Microsoft OneNote, but I use it all the time, and I personally am grateful to have it, and I'm grateful to use it, and I'm going to use it as I prepare for the upcoming interview, because I'm looking for that job where I make $100 an hour. I'm shooting my faith out there. I made $62 an hour. I made $50 an hour. I'm very grateful. When you understand, first off, that the average salary in America for black people is $28 an hour, and you're making $50 an hour, $62 an hour, that's double what the average black makes. And I understand it's because of the blessing that I got to be able to get into this world. And I want to give a shout out to the great Sharon Cochran, who was my manager at AT&T for opening doors back in 2012 for a recent college graduate from the University of Oklahoma who was hungry, and I'm still hungry today as I was way back then, and it's 2023, 11 years later, and my hope is to be in this world, in this telephony world, until I retire. And at the same time, I also believe that for the same passion I have for this, I have for the kingdom of God and serving the Lord, and that both can be done at the same time. A lot of times people tell you, if you want to go in ministry, if God has called you to the ministry, and you go to a Bible school, for example, like I did, that you must just leave your secular job and just stop. And when you look at African American people and you look at the salaries that they make, and you look at the number of African American people trying to become pastors just so they can make $30 an hour, just so that they can be able to have a congregation to maybe one day make $60 an hour in using people. When I say using people, I'm referring to offerings. I'm referring to tithes. And I'm not saying that being in a ministry and having people bless you is wrong, but I am saying for some people it's completely wrong, because a lot of these individuals really have the ability to work and preach the word of God at the same time. Yes, there's some of us that, like me, I would love to and I want to be a PhD in divinity, but I also realize I got a job to do and I got to pay my bills and I got to pay my debts, and I'm going to do just that. So that's what Cisco Collaboration Hank and my new channel is going to be about, documenting my own training and my own studies and my own going through the websites and my own reading. And it will be a way for the camera to look over my shoulder to kind of help me make sure that I'm staying on the straight and narrow, if that makes sense. So the first thing I want to do is I'm going to just organize by going over to the right, and I'm going to take this mouse when I get over to the right in the name of Jesus. What's wrong with this mouse? What is going on with this mouse? Something is weird. This mouse acting stupid. I don't understand what's going on. 1 second. Why is the mouse acting this way? Okay. Holy Spirit, I'm going to relax. Take about 3 breaths. And I'm going to say, mouse, start working. In Jesus' name. Okay, there it is, finally. It has been working. I guess problem is I'm looking at the wrong page. So let's go and click this, and now we have what we're looking for. This is my very first section of the server that I got from a woman named Lynn Zidek, and she gave this to me. I paid about $100 to $200 for it. And this was my first EXI lab. I had been working for AT&T for about 3 years. I started in 2013. And she sent this to me, and this was the old EXXI version 5. I bought it, and this thing's these servers weigh about 70 pounds. And so I had to lift, each one is about 70 pounds. And when you think about a server, man, it is crazy the amount of weight that you have to have. So Lynn Zidek first gave me this ProLiant DL360 G5 server, which I still have right in front of me, which I haven't turned on because it burns so much electricity. And then we have a backup she gave me, which was a newer version, which is a G6. And of course, guess what? They got G9s now. So my hope is to buy me a DL380 G10 or whatever off of eBay. And if I do the math right now and look it up, I can show you exactly what I'm believing God for. All right. So again, this video really is, in my way, is to make sure I maximize the 12 hours a day that I normally do my job, and make sure that I study because I know the jobs. There it is. There's a 380 G9. And let me show you what a G9 looks like. This is a G9 server. That's it's empty. They take a picture of having it full with all these different racks, but it's empty. And just imagine this goes into an office, and it can go from $700 to $2,800. Now, I probably spent over the last 10 years of my Cisco world about $10,000. I could have spent $30,000. And there are a lot of white kids and rich Asians that spend $30,000, $40,000. And that's why they got their CCIE. I'm trying, but right now, unfortunately, it costs money to make money. And unfortunately, I don't have a lot of money. So this is kind of a server that's a blank one here. There's another one here, another one here, another one here, another one here. Okay. Well, also with servers, you got what we call routers and switches. Voice routers and voice switches. So by typing in Cisco 4300 series router, this is the kind of router that I want. This is it's 150, and I'm looking forward to getting this because this is a typical router I need for all the companies today. This was in somebody's office, and basically I need to practice on that iOS and upload and update and practice getting the DSPs and all the things necessary to have access. This one has a NIM card in it. It looks like it has everything 325. So I will log in first, and then I will save it in I call it my wish list, and then believe God. But that's going to come after getting a job. So after doing the login, you got to re-sign back in. And then I can now save that. This is one that's $419. This one's $325, $199. If it's a low number, nothing's on it. So the bottom line, if you really want something, it's going to be, you're going to pay for it. They don't nothing free. I've got some old routers, but you always want to get at least a refurbished router that's new today. Probably within the next 3 to 4 years, they'll have 5000 series. If I go look up the 5000 series, there is one. There it is, a 5000 series switch. So they don't have a router yet, but that's the switch. And look at that, just for the switch. But that will come. So first and foremost, we want to say that everything starts off with our Cisco Collaboration SRND version 14. So this is what we call our Solutions Design Guidance. This is the technical standard that all of us engineers have to read. And if we read that, we walk in victory. And this is what my job is to do every day. So let me log in and save that to my memory. And that's why I'm so glad I'm doing this, because this is the stuff you don't get a chance to do every day, because you're working and you're doing all kind of stuff at the job, and you just can't work and do this at the same time, or they're going to fire you. So you got to be able to give them what they deserve, and I do. One thing about me, I have. And so this is revised on the 21st April of 2021, and we're now going into April of 2023, so I expect this to be open. The good thing is that in my previous job, unfortunately, I did not get an opportunity to do a lot of the actual design. The person that was on that job was already doing all that work, and he didn't give a you-know-what about me, and I was like, you know what, you already gave me 4 months of showing me you don't want me. I was looking for other jobs. As a matter of fact, I was interviewing for another job when I got let go from the previous job I was at, and I didn't get the job that I interviewed for because they said they didn't like the last 3 jobs that I had over the past 3 years, but like my other 8 didn't matter. And it really was racism and prejudice, and the reality is, so the hell what? I'm going to study, and I'm going to put that time in, and I'm documenting it, and I'll make sure I put timestamps on all of my videos. So when I've got 7 and 8, 9-hour videos with breakdowns, man, listen. 5 years from now, I have so many good videos that backs up my history. I'll be able to go back in time and look at what I've done. And so when racism and prejudice comes and we get the collaboration and stuff, fine, that's all right. This is a design guide and this is a base guide, but this ain't the smartest thing. What we also unfortunately have to do is we have to pay for learning. There's just no way you are going to learn by osmosis. So there's a couple of actual courses that I have learned. VoiceBootcamp.com and CBTNuggets.com and INE.com. So again, I'm putting all this at the very beginning of my video before I get into the weeds, so that whenever I rewatch this, I'll be like, yeah, man, good job, Hank. You actually was thinking about all that good stuff. This is my life. This is who I am. And there's so many different programs in so many different areas. I'm just in a Cisco voice, but there's like 70, 85 different other paths. And so the reality is that I am not going in every path. You have to find your path, and you have to stick in your path. And since I've got 11 years in this path, I don't want to go on another path. So right now they're going to send me a code to my my email or to my phone. And is my phone up here? No. But I have my email address, so let me pull up my email. And so this is great, so to show you that they don't play with email with multi-factor authentication. So log in, plug in that fact code 547795, and of course this is a one-time use only code. But this shows you just what I want to pass, and these are some serious classes. There are different upgrades and features. I currently can't afford them because I'm unemployed, but the day will come. And of course, the area that I really want to get into is my area, which is under networking. So you click networking, then under that networking level, you have different classes. They got different programs. I can't learn all this stuff. So, I have to just get away from it and go beyond. And so then you go down to, under that, you look under network areas, you go to categories, and under categories, you hit show more, and then here is my category. And this is the classes under me. So we consider to be network engineers, but most of all, these instructors here are my instructors. So now, you see what happens when you click that back button, it makes you go way back. Come on, hello. What's going on? Wait for it. Stop. All right. Looks like it won't let me click on the drop area. Hit the drop area, hit networking, go down to networking, go down to show more. Actually, go down to categories, and then show more, and then collaboration. So it's kind of called networking collaboration. That really is the under area that I'm in. And underneath that, you got basically, we got these paths. The global dial plan. We've got unified communications call manager traces, on how to get traces. We've got intercluster lookup service, network service, the unified border element, very important. Unity connection, IM presence, UCCX. Notice they skipped UCCE and PCCE, another section that we're going to talk about right now. Now they gave me a little error message, but don't worry about that. Cisco meeting server, expressway quality of service. A lot of these things, unfortunately, are becoming legacy. But if you get to a job that requires you to have to know this, you have access to it. Amen. So it's not going to be on the top of your head, but you definitely know where to go to find the information. Evolving technologies, call and mission control, again, more border element stuff, more unit connection, meter resources, gateway signaling, more contact center express, Jabber, the dynamic dial plan, mobility call coverage, phone collaboration. Really, my prayer is to get back to a service provider like I was at AT&T. Because unfortunately, the service provider that I was under, they were laying us off one by one, so we weren't able to keep growing. And that particular team laid us off. I was one of those laid off, and it breaks my heart. But you know what? I believe in faith, and I believe in God and His Word, and that God's going to bring me around. So here's the other program called CBT Nuggets. Now, under CBT Nuggets, you have to pay $59 a month to reactivate the subscription. And so I'm not, because I don't have the money. So I am as a free learner. But let me show you all of the training I have had so far. So I've completed about 463 videos, out for 53 hours worth of training, 20 hours of virtual labs and skills. And so the different types of training that we have in my world, they got, of course, all these paths. They're a lot. Each one of these, again, is a college kid starting from scratch. So for anybody like me that's 49, again, I'm 49, but I'm thinking like I'm 29, but I realize I'm 49, and I have to recognize the world's going to view me as a 49-year-old older person. We got to be real about our life, and we got to pray. Amen. Amen. So these are the videos that I have already purchased, and I've already studied, and I have them. Okay? And they're great. And so what we'll be doing in future videos is that we'll be studying some of, not the networking. We'll be skipping some of these, and let me do a search. And if you go through the names, you would have to, I hate to say it, go to my training section, and if I go under my name, go under my learning, you can see everything that I've studied, all my bookmark courses. So I have a thing called Cisco Collaboration Core 350. That is the main state course that covers the basic information, but it's not for the job, it's for a test. So if you want to take a test that only lasts 3 years, that you got to retake every 3 years, fine. But the reality is you got to be able to do the job. And that's this test does not explain the job. This test only does one thing, is that it basically it's kind of like a little bullshit to kind of block you out. But the fact of the matter is, I believe God will open up other opportunities to me. So, for example, there's remote engineer jobs. I've got people from LinkedIn reaching out to me. And the biggest thing that I'm waiting on is the right roles that I really wanted. And I'm hoping in God I will find that. There is a network engineer role that they will love, that people love us to go after, because it's always the need for network engineers. And I would love to go on network, but for now I got to master my voice. Then I can go master network. But you need to get the CCIE in voice and then go network. And that's the way I want to be. So Lalo Nunez is the guy who teaches that. And so I also got another class that we have to study called Advanced Call Control Services. So this one is the main course. This is the second course. And then there's a third course that's called the WebEx. And this is the new WebEx course. And I only done a couple on the WebEx. But they're classes, and these are called playlists right here. So playlists are just where I can actually play back, but you have to first pay the $59 and actually and get in. So let me show you all the training in the all training path. Actually, let's go there, and then once we click on the drop down, you see this. Look at all these skills. I mean, God, there's no way you're gonna get 1,500 hours of training on everything. You have to pick your section, correct? So after you pick your section, which in this case is this right here, collaboration, it opens up the courses. And as you can see, 38 hours, 322 videos. I have all the videos. You actually can see it looks green, showing that I've already watched the videos. And so what I got to do now is I got to rewatch them. So over this next 3 weeks and that I'm unemployed, I will keep making sure that I watch those videos again, because again, those videos are priceless, and there's different skills. So you have skill 1, and let's kind of do that. Let's talk about each skill right now and document this so that we kind of document where our brain's supposed to be going. So skill 1 is talking about introduction to communication and audio basics. Skill 2 is collaboration. Skill 3 is collaboration design elements, or key design elements. Skill 4 is Cisco Collaboration Edge devices. Skill 5 is collaboration install. And there's like 38 skills, so there's a lot of skills. Installing the call manager into your VMware or vSphere virtual machine. Then we have phone boot up process for any phone that you give to that person, and they go plug it into a jack or switch, and then it gets to the My Call Manager. Then we have the Call Manager at the first look, and this is Call Manager 12 and 14. The core network components, how we configure the network components, how we configure LDAP and the certificates to get to the company's LDAP or lightweight directory access protocol for all the employees that are hired into the company. And one of the benefits that I can say that have coming from being on the service provider side and working with customers, and I hope that this conversation will help me when it comes down to questions and answers for interviews, because unfortunately, when interviews, I can go 5 minutes on one question, but if racist white people don't like you, then they'll say you went too much, and they'll find some way of not saying you ignorant, but they'll say you said too much. Now, that's bullish, but the reality is you got to say too much before you can say too little. So, because either way, if they want to hurt you, they can always say you don't know enough or you know too much. So, like LDAP and certificates, then DHCP and DNS. Then we get into the beautiful session initiation protocol. Huge session. This is a whole study of itself for being able to go on the routers and get the traces to analyze why certain calls don't work. That was pretty much 99.9% of calls at a company that we're doing is I got a spam call from 10 zeros, plus 0000000, and this person's hiding their phone number. I need to know how we can block that call. Well, you got to get the SIP traces of that call to be able to go analyze it. And there are teams at Cisco that they don't do advanced stuff. They just do the basic SIP traces. And they're masters at it. And so if they can be masters at it, I can be masters at it. And that's the area that we want to go into. Then we get into call manager regions and locations. Then we get into the provision endpoints, the BAT tool, troubleshooting phones that don't register, troubleshooting router gateways that are not working properly. That's a huge area. Again, going back to the SIP part. Then dial peers, big area. I want to really go back over and study that. Then voice translation rules and profiles off the router. So all this is the router gateway. Then voice gateway DTMF and codec configuration, big area. Then media resources, big area. And then all of that builds into what's called the Unified Border Element Cube. And that's or SBC, Session Border Controller, big area. Then we get into routing concepts. Then a call routing demo. Then translation patterns and transformation patterns on the call manager. Then partitions and search spaces on the call manager. Then toll fall prevention on the call manager. Then quality of service problems, which I haven't had to do that in most of my jobs, but it's still part of the exam and it's still an area to study. This section starting at QoS and describing another QoS product called DiffServe, that is a big area that you really got to study because I haven't done that ever. QoS requirements, QoS class models, Q quality of service policies, MOC and LLQ, which is another quality of service policy, and how to configure it. Then we go into Unity Connection. And then we go into Unity Connection mailboxes and call handlers, which I used to build at AT&T. And then we get into Unity Connection endpoints. And then we get into the presence caller. And then we get into Jabber on premises, DNA, real-time monitoring tool, and then auditing and CLI commands. And these are all the main skills. And within those skills are 388 videos. Think about that. For all those skills, the videos are 388, and they take about 38 hours to watch, but really 155 hours to really master. And that's just the basics. That ain't even advanced class. There are more. So even after that, you've got more classes in collaboration. And so we have a new one they just came out with called Cisco Collaboration Solutions Architecture, which I think probably is great. I don't have this. This must be new. And so we click on that and we can see it's this video. And this basically talks about, this course is prepares me describe the suite of collaboration technologies, architectures available for maintaining them for any organization, but definitely for enterprise companies, major companies. Choosing a solution, making changes to that solution is expensive, right? So they want me to be able to know how to help them do that. In essence, become the SME, which is the ultimate goal for me. So then we kind of start over from scratch. Notice this matches up somewhat with the previous class, but there's going to be some differences. So if I go back and I hit the close, I can go through the skills. That's the same. So if I say same, just note that this is the same as the other class, the basic foundational CCNP collaboration 2020 class. So same, and same. Wow. So basically all this is a new class that divides the previous class that had the 38 hours or 38 hours of information, 322 videos. It just chopped it down in a small section. So the best thing is this class right here, which you already got. But then I have another area which we'll get to in a minute. So for me, I would want to, first off, knowing that a lot of companies are going to WebEx. My argument is start studying WebEx. So they got some WebEx classes. This is one of them called WebEx API. And this is the intermediate class. Once you're done with the WebEx training, you'll know how to implement and use ChatOps. And this basically is a program for us to be able to do what's called creating a team room, Python request, posting message to a room. This is more about ChatOps. This is after they have WebEx. So the first thing will be what is WebEx, right? And so one of the things that every company has is different strengths. There's strengths with CBT nuggets because they give you good nuggets that you can watch daily and get and just really sink that information in. But you must watch daily. Then for the here, you got the networking, as I just showed you, collaboration. And as you can see, 11 hours for this global dial plan. 11 hours. What you notice is if you buy a starter subscription, it says what's included and what's not included. So you see the word included there, but then you don't see included here. So what they're doing is they're hurting you by making you have to buy the upper $800 1-year class, a 1-year subscriber fee to get access to some of these really important classes. And in my space, to make $100 an hour, I have to get these in my head, in my notebook, in my OneNote, right? So, for example, this class. So when you click on it for like this one, it's 11 hours. It's not going to play anything because it says active, but I doubt very serious. Whoa. Whoa. Are you serious? Wait a minute. I thought that I did not have a, it says I have a starter pass. I don't know what that means, but we're going to play this and we're going to document this in the video. Again, this is being live streamed to my my YouTube channel. We may have to make this video private if this works, because again, I am actually playing somebody else's native, somebody else's documents and stuff like that. But let's click the start video. This might be a great start. Let's go. It's working. It's working.
Hello and welcome to INE. For some of you who do not know me, my name is ROHIT Pardasani and I am a full-time instructor with INE. I have 5 CCIE, CCIE and route switch, security,
CCIE.
Service provider, voice and collaboration.
Look at this, service provider, voice.
So what exactly
route
are we going to be learning in this course? Well, the first thing that we would focus on is going to be about dial plan fundamentals. So here we would talk about what are the key components required for you to build a dial plan implementation, or maybe a design for dial plan. So what are the key components? This is what we would be talking about in the dial plan fundamentals. The next thing that we would look at would be elements of dial plan. Basically here we would look at things like partitions, calling Cert spaces, where do we use the partition, when should you use, whether you should use it under the device or device-based approach, or we should do it under the line. So here we would focus on that. The next thing that we would look at is going to be dial peers. So again, dial peers becomes a really important part when you design or implement dial plans, because you may have calls going in through the cube. So that's where the dial peers would come in. So we would focus on dial peers also. Again, if dial peer comes in, then obviously voice translation rules comes in, because again, the carrier requirements may be for you to send local, national or international calls in a particular format. So that's taken care of with voice translation rules. The next thing that we would look at is advanced elements of dial plan. For example, we would look at time of day call routing, where the call manager can route calls based on time. We would look at forced authorization code. We would look at client matter codes. We would also look at standard local route groups. So this is where we would focus on in this topic, where we would look at the advanced elements of dial plan. After this, I would show you a demonstration of the advanced elements of dial plan. So we would actually look at we would implement time of day call routing. We would test authorization codes, force authorization codes. We would test client matter codes. We would create standard local route groups and test calling. The next thing that we will focus on in this course would be traditional versus globalized dial plan. So what exactly was traditional dial plan implementation and what is globalized dial plan implementation? So here we would focus on that. The next thing we would look at is a demonstration of globalized outbound dialing. So here we would have call managers connecting with Cube taking the call to the SIP IDSP. So again, we would globalize the call coming into the call manager, and we would localize this maybe at the Cube or maybe at the call manager. We would also look at globalized inbound dialing, the benefits of that, and maybe globalizing it at the Cube or at the call manager, and again localizing it at the call manager. So here's what we would look at for globalized inbound dialing. The last thing that we would look at is going to be globalized dialing again, outbound dialing and inbound dialing, but this time it's going to be through SME. So again, we would look at the advantages of using the SME in your design. So call coming in from, let's say, a phone would be in a localized dialing habit, and that would be globalized by your call manager and then sent to SME. The SME would send that to Cube, and the Cube would localize it as per the requirements of the SIP IDSP. Basically, this course is the perfect course for anyone who is planning to attempt for the CCIE Collaboration version 3, because dial plan is a pretty important section in the lab exam. I hope you enjoy this course, and I will see you in my first video. Hello and welcome to INE. Today in this video, we would talk about dial plan fundamentals, which is the core component to understand the global dial plan. So the first thing what we need to understand is what exactly are you going to be learning in this video. So in this section, we would basically talk about where calls originate from. We would look at what type of patterns can be dialed. We would also look at digit addressing methods and pattern matching logic. Now, where do calls actually originate from? If you look at from perspective of a user dialing, a call could basically originate from a phone. So a user places the call from the phones. We could also originate calls from gateways or trunks, where a call can come in from a PSTN or a SIP IDSP, or even in fact a trunk partner. Maybe you have a trunk with maybe an intercluster call coming in from a different UCM, or it could be call coming in from a queue. We could also have calls coming in from voicemail ports or CTI ports. Basically, a call can come in from voicemail message. So maybe you have the call getting redirected to the voicemail, and maybe the voicemail has auto attendant configured, and the call has to be rerouted back to the UCM, maybe going to the PSTN. So we could have even a call coming in from the voicemail ports or from an IVR redirect. Basically, your CDI ports for UCCX, we could also route calls from there. So calls can come in from UCCX also. And then we have translation patterns. So translation patterns are also something where the calls can come in from. So let's say a user dials some digits, which could be digit by digit or an end block. So the calls gets transformed and it's sent back into the system to the UCM for further digit analysis. So these are the places where calls can usually come in from to the system, which could be from the phone, could be from the gateway, or your voicemail, or your CDI ports, UCCX, or it could even come from translation patterns. Now, what patterns can be dialed? The reason I'm actually talking about this because there's a lot of confusion which I've seen even during boot camps where sometimes people feel that there has to be some order in which the patterns are normally dialed. However, all patterns are considered equal. They basically hold the same preference. There's no specific order for what pattern holds more precedence over something else. Everybody is considered equal. So all patterns are considered equal. If you look at the different types of patterns that actually can be dialed, we have route patterns, we have translation patterns, we have directory numbers, we have calling party transformation patterns and called party transformation patterns. In fact, here is something that I would really like to talk about is, like I said, there's a lot of confusion where people feel that, okay, route patterns can be dialed, but calling party transformation cannot be dialed. Well, calling party and call party, they can also be dialed. That's why it's really important that you restrict call party and calling party. You do not give the phones direct access to calling party and call party, because what does that actually do? When let's say a user dials a specific digit, and if it matches the pattern of the calling party, the call would be routed to the calling party transformation or the call party transformation. Does it do anything? No. So basically it becomes a black hole. You don't really want your phones having direct access to calling party and call party transformation. Route patterns, they are routable, so that's okay. But calling party and call party, they are routable, so you should never give your phones direct access to them. But yes, they are again considered equal. So there's no precedence that route pattern has more precedence or more preference over calling party transformation. They all have the same preference. They all are considered equal. Then we have meet me patterns, we have voicemail ports, we have hunt pilots, and we have call park or call pickup. So these are some of the patterns that actually can be dialed by the user. You just really have to be careful what permissions or what restrictions you want them to have. You should be really careful by creating partitions and class of service. So this basically means that without careful use of calling search spaces and partitions, the wrong pattern could be dialed. So maybe a user is trying to dial a local call, and his calling search space has access to the partition also, which is for calling party transformation or call party transformation. It would match that, and the call would be routed to the calling party transformation, but from there it would not go anywhere. So basically, your calling party transformation pattern could be dialed, could be accidentally dialed instead of the desired route pattern or the translation pattern. So you really have to be careful about that. Then we have the digit addressing methods. As you know that we have different types of phones with different types of firmwares. Mainly two main firmwares that we have is Skinny and SIP. As far as Skinny is concerned, Skinny phones are concerned, they support digit by digit or they support en bloc. Digit by digit is something where, let's say you go off hook and you press 9, the station sends an init message to the UCM. The UCM message may send back a directive, which could be like maybe a reorder tone or could be a message back. So in digit by digit, every time you press a digit, it actually goes and sends that to the UCM, and the UCM sends back a message back. So Skinny phones do support that. As far as en bloc is concerned, the entire block is sent together. So for example, to do en bloc, you would not pick up the receiver or go off hook or go on speaker. You basically dial all the numbers first and then you go off hook or press the speaker button. Another way to send en bloc would be maybe you hit the missed calls button or the corporate directory or the place calls. or maybe even the speed dial. So in N block, the entire block of all the chunk of numbers are sent together to the call manager for analysis or to route the call. SIP, as the firmware, phones also support SIP. So SIP supports KPML, which is keypad markup language. It's again like skinny digit by digit. So SIP phones do support KPML, and it supports N block also. However, there's one more in SIP, which is SIP dial rules. This is something that you would really not find in today's environment. It's basically for the older phones, where some of the old phones did not support KPML, so they could not do digit by digit. So in that case, the phone would download the dial plan setup from the UCM. And as soon as I go off hook and I press, let's say 9, nothing is actually sent to the call manager. The phone locally analyzes based on the dial plan that it has downloaded. It actually analyzes the digits locally, and once it matches the entire set of digits, it then sends it to the UCM as an N block. So SIP dial rules are something that you would find in older phones. And it's like KPML, but the only difference is that in KPML, one by one, the station sends the message to the UCM. So it sends digit by digit to the UCM. However, here in SIP dial rules, the phone does not really send anything to the call manager. It does not send anything. It analyzes the digits locally because it has downloaded the dial plan. Again, something that you would not see in today's environment. Maybe back in the days when you had the 7940 phones, they would kind of support the SIP dial rules if they had the SIP firmware, but you would not find this anymore. And all new phones do support KPML. Gateways, for example, MGCP, S.323 or SIP. Again, we can have N block there, or we could have overlapping sending and receiving, which was always there in the PRI. N block again is the same. We send all the entire block together to the call manager, or the gateway sends the entire block down to maybe the trunk or the MGCP or the queue. It sends the entire N block. The overlapping sending and receiving is something like digit by digit. So it's always been there in PRI. But in fact, even trunks like H.323 or SIP, even they support N block and overlapping sending and receiving, which is like digit by digit. Translation patterns. They are always sent back to the call manager for further digit analysis. So translation patterns are something that you would really use quite a lot. And I would actually talk about this extensively in some of my other videos, but something that you would normally use for maybe transforming something. Let's say the user dials 7 digits or 9, a local number basically, and it hits a translation pattern, and the translation pattern can maybe transform or make some changes and send it back to the call manager to match maybe a route pattern. Typically, you could match even a translation pattern again, but normally it would be a route pattern. So let's quickly understand the pattern matching logic. That how does the call manager actually match the digits which are sent from the station? How does the call manager select which route pattern or which DN to basically match? So if you look at the first example here, we have 9 dot square brackets 2-9 close square brackets, and then we have 6xxx. So here the dot is basically considered as the delimiter, which does not match any digits. It is used for discarding. So anything which is before the dot basically gets discarded by the call manager. He would not consider that for call routing. Then we have the open and close square brackets where we have 2-9 inside that. Now, as far as that is concerned, here 2-9 basically means that it would match a range of digits between 2-9, 2 and 9 inclusive. So it could be either 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. It's not 2 and 3. It's any one digit between 2-9. Then going back to the XXX, that's a single digit between 0 and 9. It does not match. It does not really match like asterisk or pound or plus. It only matches a single digit between 0 and 9. So a typical example for this first one would be, let's say if I was dialing a local call, maybe I was dialing 9-202-2001. So here 9 is going to be discarded before when it goes to the call manager. The call manager, before it routes the call, 9 would be discarded and 202-2001 would be sent across to the gateway. If you look at the second example here, we have 9.011, and then we have the exclamation, or I like to call it the bang. So here again, before the delimiter is the dot, so 9 would be discarded. The bang basically means one or more occurrences of digits between 0 and 9. Again, the bang does not include asterisks or the pound. So it's anything between 0 and 9. So it could be 90111. It could be 90112. So it could be one digit or it could be 10 digits. Doesn't really matter. It could be as many digits as you want. However, to avoid interdigit, you must give the pound, which is the octatar, or you may call it the hash or pound. So this is used to avoid the interdigit timeout. So let's say if I do not give the pound, I just give it as 9.011 and bang. In that case, the user would have to dial 9.011 and then any number of digits. It could be a single digit or it could be 100 digits. Doesn't really matter. But he would have to wait for the interdigit timeout. Going back to the last one, which is 9.at, which is basically a macro that calls a numbering plan into consideration. It's really not utilized in the CCIE voice. In fact, this should be CCIE collaboration. This is a pretty old slide. So this is actually CCIE collaboration. So it's not going to be tested in the CCIE collaboration lab exam. So, but something that you should know that the @ sign basically is a macro which calls for a numbering plan and that uses a route filter logic. So here are some of the examples of the patterns that can be used in the call manager. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, asterisk, pound, matches exactly one keypad button. So if I dial 9, it matches that. If I dial pound, it matches that. X matches any single character. So if I look at X, X is any digit between 0 and 9. The next one is 1, 2, basically open and close square brackets. We have 1, 2, asterisk 5, matches any of the 1 digits between the open and close square brackets. So it could match 1 or 2 or even the asterisk or 5. The next one is again open and close square brackets, 4-9. Here it matches 4 or 5 or 6 or 7 or 8 or 9. Remember, it is inclusive of 4 and 9. And the next one is kind of like a negative effect. So normally the caret sign, that indicates in regex, it actually indicates beginning of line. However, if you use the caret within the open and close square brackets, in that case, the caret basically means a not. It's a Boolean not. So this something here, this would basically match anything that is not 3 or 4 or 5 or 6 or 7. So basically this would match either a 1 or a 2 or an 8 or a 9. So, or in fact, even an asterisk or pound, it would not match 3 to 7. So when you have the caret within the open and closed square brackets, it becomes a Boolean not. And then we have the bang, which is 1 or more digits in the range of 0 to 9. We have the question mark, which is 0 or more occurrences of the previous wildcard. We have the plus sign, which is 1 or more occurrences of the previous wildcard. And then we have the @ sign, which I discussed earlier, which was the macro for the numbering plan. And there's something which is blank. That's also a pattern. So let's say if I have a pattern which doesn't have anything, no digits, even that is a pattern, which immediately routes the call with no digits. This is something which could be used in an environment where, let's say you want a user just picking up the call, he just picks up the receiver and it dials someone. For example, maybe the commissioner wanting to call Spider-Man. He just picks up the call and it dials Spider-Man. So that's something that can also be used as a pattern. So here are some examples of call manager pattern options. So if you look at the first one, we have 1111. That matches the exact DN or the route pattern, which is 1111. I have asterisks. I have asterisk 1, asterisk 1. That matches again asterisk 1, asterisk 1. I have 12XX that basically matches numbers between 1200 and 1299. I have 13 open and close square brackets 25-8 and then 6. This basically matches 13. And then in the brackets, it's going to match either 2, 5. So it's going to match 2 or 5. So if you look at the matches, it's going to be 1326, 1356, 1366, 1376, 1386. The 1, 3, and 6 at the end, the 1, 3 at the start, and the 6, that has to match. Within the square brackets, it's going to match either a 2 or a 5, not 3 and 4, 2 or a 5 or a 6 or a 7 or an 8. And then we have the next one, which is 1, 3. Again, if you remember, the caret within the square brackets, it's a Boolean not. So this would match 1, 3. Not 3, not 4, not 5, not 6, not 7, not 8, not 9, which basically means that it would match 1316, 1306, 1326, 13 asterisk 6, 13 pound 6. And then the last one, which is again an example, would be 13 bang and then the pound. So here this matches anything that begins with 13 with followed by 1 or more digits, but it must end with the pound sign or the hash or the octatar. An example would be 135 hash or 13579 hash.
It could be any number of digits. The pound basically has to end the string, but the bang means any number of digits. So if you remember, we earlier discussed the @ sign, and if you remember, I told you that this was a macro for the numbering plan. So here, if you see, I have the 9.at, which basically maps to a North American numbering plan, which could be like a 911, or could be, so again, this is 92-911, which could be 911, or it could be 9411 for information call, or it could be 9.2-9XXX. Again, this is for local calls or national calls, which normally has the 1, so 9.1, which is for national call, and then we have international, which is 9.011. So the @ wildcard represents all the routes defined in the national numbering plan. So what's going to happen here, how does the call manager identify what you're dialing, is basically based on the route filter. So let's say if I was dialing a local call, right? In the local call, I would not have 9.1. So the 1 would not be there because a local call starts from 2-9, 2-9. So if I was doing a local call, the call manager would use the route filter logic, which normally you would have to create tags. You would have to actually go to the call manager and create a route filter. It's actually called, I believe it is like a policy. So you go to the call manager and create a tag, which basically says that I could have tags like international access, area code, office numbers, and so let's say if the user is dialing a local call, which is not national, which is not international, the call manager would go through the route filter logic, which basically says that, okay, international access does not exist and area code does not exist. So the call manager would present just the 911 and the local calls which is available to the user, so you cannot dial international or national. So the @ sign has everything as a macro, but how does he eliminate which one is he dialing, which is based on the route filter logic. So I actually have to go and create that route filter logic. In fact, I think I do have a slide which represents the route filter configuration. So here is the route filter configuration, which I would go on my call manager and create a clause. So here I have the clause set as area code exists, and the Boolean is the and here, which says area code exists and international access does not exist, which basically means that this is for national calls. So I would actually create multiple clauses on my call manager. So that's how the call manager would filter based on what he's dialing. So if he's dialing a national call, it would match this clause which says area code exists, but the international code, which is 011, that does not exist. So he is dialing national at this point of time. I could make another clause which would be area code does not exist and international access does not exist also, which means whatever he's dialing does not consist of 91. So 1 is not there, and 011 is also not there. If that's not there, present him with just 911 and local calls. Again, this is something that I highly doubt that they would test you on, something that you should know about, but I don't think they would test you with the macro and creating route filter configuration on the call manager. I really doubt that they would test this, but something that you should know. So here's an example of how the call manager does routing, or how does he route the call, which patterns it matches. So if you look at the first example here, the user dials 1200. Now on the right side here, I have some patterns, and it actually does not really matter whether the patterns are in one partition or they are in different partitions. It doesn't really matter, because the first thing that the call manager does is it will always try to match the longest match, exact match. So here, if you look at, let's say the user dials 1200, and let's say all of these three patterns, 1xxx, 12xx, and 1234, let's assume that all of them were in one partition, okay? In that case, when the user dials 1200, it matches, again, let's say if he's doing n block, then it would match the second one, which is this one. It would match this one. The only reason being it's the more exact match, because this one is 1xxx and this is 12 and xx, and this one does not match because he's dialing 1200. However, let's assume that maybe this was in partition A and this was in partition B. And the phone has access, the phone CSS has access to both the partitions. And maybe partition A was up the order and partition B was down the order. Okay? In that case, normally you would think, yes, partition A takes preference, right? Because, partition order matters. However, it only matters if the patterns are exact match, if they're the same. If you look here, I have in partition A, which is up the order, I have 1xxx, and partition B, I have 12xx, and if the user dials 1, let's say he is not doing n block, he is doing digit by digit, he picks up the receiver, he dials 1. At that point of time, it matches all three. It matches all the three route patterns. Then he dials 1, 2, so 2. When he dials 2, it matches again all three. When he dials 0, the last one is eliminated, and now it matches just the one which is in A and just the one which is in B. When he dials 0 again, it still matches the one in A and matches the one in B. Now, which one would he choose? See, he dialed 1200. The last directory number, 1234, is eliminated. But the first two, which is A and B, they both match. A is up the order and B is down the order in my partition order configuration. So normally you would think, yeah, A should be the preference, so it should use the one which is in A. But that's not the case, because 1, 2 is a better match than 1x. So he would use partition B. Even though partition B is down the order, he would use partition B to route the call. If you look at the second example, I have 1, 2, 3, 4. Again here, let's assume that I have maybe my 1xxx is in partition A, up the order. 12xx is in partition B, which is down the order. And then 1234 is in the none partition. The none partition has the least preference. So what's going to happen? Again, let's say the user dials digit by digit. He picks up the receiver, and he dials 1. At that point of time, it matches all three patterns. Then he dials 2. It still matches all three patterns. Then he dials 3. It still matches all three patterns. Then he dials 4. It still matches all three patterns, all three route patterns. Now, after the interdigit timeout, what's going to happen? How will the call manager choose? A is up the order, B is below, and none is here. Which one would he choose? Again, here he would choose the none, because none is an exact match. So it doesn't matter whether your partitions are up the order or down the order. It doesn't matter. The call manager will always use the longest match logic. If when does the partition order come in effect? Is if I match two patterns. Let's say the A was not 1xxx. The A was 12xx. B was also 12xx. In that case, if I dial 1200, both A and B matches, and they both are exactly the same. In that case, A would be used because A is up the order in the partition and B is down the order. But if the route patterns are not the same, B has a more exact match, a longest match than A, it doesn't matter whether A is up or A is down, that specific B would be chosen. And here is another example, again expanding on what I was discussing earlier. So a user basically goes off hook. When he goes off hook, the call manager, he basically sends an init message if I was doing digit by digit. So he sends an init message, the phone sends an init message to the call manager. The call manager says, provide dial tone and wait. At this point of time, if you look at from digit analysis perspective, my DD is blank right now. And these are the list of partitions that the phone CSS has access to. It has access to internal, EMS, local, national, international. So since he has access to all the partitions, the phone CSS has access to all the partitions, the call manager would see, okay, the list of route patterns that may match at this point of time without him dialing anything. He just picks up the receiver, the call manager sends provide dial tone, and he waits. He waits for you to dial something, send some digits. So at this point of time, all the route pattern matches. It matches 7100, 7201, or 72XX, or 73XX, or 75XX, or 756, or 70 through 5XX, or 75 bang. It matches everything at this point of time. So the list of potential matches is everything. The next thing, he dials 7. At this point of time, if you look at my DD, it shows 7. So he's dialed the digit, my dial digit is 7. Again, at this point of time, based on his list of partitions that he has access to based on his CSS, I have all the potential matches listed here. Then he dials 7-2. At that point of time, the call manager would eliminate 7100 because that doesn't match. He eliminates 756 and 75 bang. They are basically eliminated, and the only match that I have is 7201, 7235XX, and 7035XX. These are my only 3 matches. Then the user dials 720. At that point of time also, it matches all 3 of them. Nothing has been eliminated at this point of time. The next he dials 1, which means my dial digits become 7201. Again, it matches this one also, 7235XX. It matches 705XX also. But because 7201 is the longest match, doesn't matter which order my partition is in. It could be in PT none, or it could be lower order partition. It doesn't matter. If it is the best match, longest match, that the call would be routed using that route pattern. Hello and welcome to INE. Today in this video, we will look at the elements of dial plan. So in this video, we would basically talk about dial plan elements, calling search spaces, partitions, building class of restrictions, and traditional class of service construct. We will also look at the traditional dial plan. How does the traditional dial plan look like? We would not be configuring anything at this point of time. Maybe in the next video we would do that, but in this video we will just look at the basic concepts that you need to understand. So what are the major elements of the dial plan? Well, the dial plan elements consist of calling search spaces, partitions, route patterns, route list, route groups, gateways, translation patterns, calling party transformation patterns, and call party transformation patterns. Again, if you remember from my previous video, calling party transformation and call party transformation patterns, they can be dialed. So creating calling search spaces and partitions becomes extremely important because you don't want the phone to be dialing the calling party or call party transformation because it does not really go anywhere. It is only used to transform the digits. It's not used to route the call. So coming back to looking at the first major element, which is calling search spaces and partitions. So basically, let's say we have a DN 1001. This DN is put inside a partition. Think of the partition like a phone book. Like back in the days, we had the white and yellow pages, which basically consist of all the phone numbers of all the businesses. I mean, it's not there anymore, but back in the days, if you were born before 1990, this used to be there where we had this book which consists of all the phone numbers of all the businesses. Think about partitions exactly like that. A partition basically consists a list of directory numbers or route patterns which is inside that partition. So your phone book is the partition. Now, for you to be able to dial a phone number, for you to know what's the phone number of a business, you need to have that phone book, right? So that phone book is basically inside a calling search space. Think about the calling search space like a file cabinet, which consists of many yellow pages or many books, which basically contains your partitions. So your DN goes inside the partition, or your route pattern goes inside the partition, and the partition is inside the calling search spaces. And finally, the calling search space is assigned to the phone or the gateway. It's basically assigned inbound. So let's say if the phone wants to dial 1001, he would look at his calling search space. He would scan through the partitions, the yellow pages or the book, and see, do I have access to the directory number or the route pattern? Do I have access to that? Similarly, the gateway can also be doing the same thing. The gateway can have access to the calling search space. Again, the gateway is not going to be dialing himself. Basically, what happens, let's say if the gateway was sending the call to a SIP IDSP or the PSTN or maybe a trunk partner. In that case, before he sends or routes the call out of the UCM towards the remote partner, before he does that, the gateway could use the CSS and route the call to the calling party transformation. It's actually not routing the call. It's not actually going there. It's just the COLLAB number could be sent to the call party transformation to transform and then loop it back in to the gateway so that he can send the change or the manipulated digits to the PSTN. So pretty much everything that has a directory number or a route pattern could be assigned a partition, and which could be inside a CSS, and CSS could be applied inbound to the phone or the gateway. The calling order is, again, it's from down to up. So it's the phone which needs access to the CSS. The phone should be assigned the CSS, and the phone would look through his cabinet for the yellow pages for the partitions, and that's how he knows what to dial, or does he have access to dial that. that directory number or the route pattern. Here's an example, an expanded example of what I was talking about earlier. So I have two users here. I have Anna and I have Tony. Anna is 4001 and Tony is 2002. Now, if Anna wants to dial Tony, Tony is in the partition Avengers Yellow Pages. However, when Anna tries to dial 2002, the phone would look through its cabinet of directories, its filing cabinet, and see what yellow pages do I have in my cabinet. So as per this diagram, Anna has INI yellow pages and has the Universe yellow pages. She does not have the Avengers yellow pages. So can she dial at this point of time Tony? No, because she does not have the Avengers yellow pages. So the call would not be placed. Basically, the call manager would send back a reordered tone and the call would not go through. However, if I go and add the Avenger yellow pages to the filing cabinet of Anna, in that case, she would be able to dial, or the call manager would route the call to Tony. So all we need to route the call is we need to ensure that the DNs or the route patterns or the translation patterns or the call pickup or the meet me number, they all are in a partition, and your device, your phone or your gateway has that partition in the CSS which is applied to that device. So looking back at this example, if Anna does have Avengers yellow pages in its cabinet of directories, Anna would be able to dial, or the call manager would route the call. Again, expanding on the partitions, if you remember, I did speak about this in the earlier video where we looked at some examples of partitions. So again, looking back at this, where I have a phone which is trying to dial 1001. Now, assuming the phone has a calling cert space, again, if you don't assign a calling cert space, he would still have a calling cert space, which would be the CSS none. The none is basically for everyone, and the CSS none has partition none. But looking at this example, let's say the phone or the device has the CSS A, and the CSS A contains partition 1 and partition 2. So here, again, the order of the partitions don't really matter if your match is not the same. So in this example, in partition 1, I have 1XXX and 2001, and in partition 2, I have 10XX and 2001. Now, if the user is dialing 1001, how's the call manager going to look at it? Again, partition 1 is up the order and partition 2 is down the order. However, when he dials 1001, it matches partition 1 and it matches partition 2. However, in partition 1, who is up the order, it is 1XXX versus in partition 2, which is down the order, it is 10XX. So technically, it should have matched partition 1 because the order matters, but because the match is not exactly the same, the call manager always looks at the longest match. In partition 2, it is 10XX, so that's a longer match than 1XXX. The call would be routed through partition 2, and wherever that route pattern which is in that partition 2 would be used, and the call would be routed out to the gateway. So again, the partition only matters, the order of the partition only matters if the DNs or the route patterns are exactly the same. If they were the same, then yes, partition 1 would be chosen. But in this example, partition 2 would be chosen because that's a longer match. So let's say now if he's dialing 2001, does he have access to partition 1 and partition 2? Yes. His CSS has both the partitions, partition 1 and partition 2. Partition 1 is up the order, partition 2 is down the order. However, when he dials 2001, it matches partition 1 and it matches partition 2. They both are longest match. They both are the exact match of 2001. In that case, the partition order would be used as the tiebreaker in case of equal matches. So in this case, partition 1 would be chosen, and that's how the call would be routed. So again, looking at the CSS and partitions, expanded usage. CSS traditionally used for matching the dial digits and routing translation patterns back into the dial plan. So like I said, that we could use translation patterns inside a partition, or we could use route patterns inside a partition, and we could transform things using calling party transformation. We could transform those things. We could transform the digits. We could transform calling number, call-aid number. So CSS and partitions can be used for that. However, it's actually used for much more than that today. So it's not about just restricting a phone to not have access to a certain DN. It's not about just that. It's much more than that. So it is used for routing digits off to be transformed or manipulated. And so again, like I said, that if the gateway who's routing the call to the PSTN or the SIP IDSP, if he wants to make some changes, if the gateway wants to make changes to the call-aid number as per the requirement of the SIP IDSP, the gateway could actually send the call out. Before he actually sends the call out to the gateway or out to the PSTN, what he could do is send the call to the calling party transformation. He's actually not sending the call, but he's just taking the call-aid number, giving it to the call party transformation, transforming it, and looping it back into the gateway so that he can send the manipulated number or the manipulated call-aid number to the PSTN. It can also be used for determining BLF presence status. Again, this is something that we can use CSS and partitions for. So let's say if you want to monitor a specific DN, you could do that with CSS and partitions. Again, you don't want everybody in your organization to be able to monitor the HR, but you want a specific person. Let's say if I had to dial the HR and that HR person is busy, I'm not going to dial, right? But if I configure BLF, then I can actually see that the HR is busy at this point of time, and I may dial later and not right now. So I could use CSS and partitions for even BLF and maybe have certain users or certain phones giving them the ability to monitor the status of a remote phone. It doesn't matter whether the remote phone is local to the cluster or through a SIP trunk. It doesn't really matter. We could still monitor the BLF presence status of that remote device or remote phone. So coming back to the legacy config order and digit manipulation, again, this is from perspective of, let's say we're talking about the traditional way or the traditional dial plan construct. So there are three parts to this. We have route patterns, we have route list, and the route list consists of the route groups, which basically consist of the gateways. So the route pattern matches dial numbers for external calls. It points to a route list for routing. The route list points to a prioritized group, and the route group points to the actual devices or the actual gateway. The gateways could be MGCP, H323, SIP. It could be trunks like H323, ICT, or SIP. Any of the gateways can be assigned to the route groups, which is normally assigned to the route list, and the route pattern uses the route list. Now, again, something that you should know about. Now, back in the days, which is from Call Manager 9 and before. If you assign a gateway to a route group, then that gateway cannot be used by the route pattern. You cannot directly call the gateway in the route pattern if it was already used by the route group. However, from Call Manager 10 onwards, that's changed. You can now assign the gateway to a route group. At the same time, you could use the route pattern directly calling the gateway. You don't need to assign the route pattern to a route list. You could assign both, because sometimes you really want, let's say for testing or something, you just want to route the call directly to the gateway. You could use that, which is a pretty good feature, which they've added from Call Manager 10 onwards. So in the lab exam, currently we would be using 12.5 in the lab. So you could assign the gateway to a route group. At the same time, for some other patterns, we could also, the route pattern could directly use the gateway also. Now, the only reason, if you look at this diagram, in fact, we have route group 1, which has a gatekeeper. In fact, gatekeeper is something that you would never find anymore. I don't think anybody uses the gatekeeper anymore. This is actually an old diagram. So replace the gatekeeper with cube. So route group 1 has a cube, which connects to the SIP IDSP, and route group 2 again has 2 gateways. So in the route group, we have a distribution algorithm which we can use to distribute how we want to route the calls. So there are 2 distribution algorithms, top-down or circular. Circular is the default. So how does circular actually work? So let's look at this route group 2. In the route group 2, if you set the distribution algorithm to circular, which is default, in that case, the first call would be routed to the first gateway within that route group, and the second call would be routed to the second gateway, and then again the first, and then again the second. So the first call goes to gateway 1, second call goes to gateway 2, third call goes to gateway 1, fourth call goes to gateway 2, and so on. This is circular. However, if I do top-down, in top-down, it's different. So the distribution algorithm changes. If I change that to top-down, then let's say if I had, maybe if I had 2 groups again, or maybe 3 groups again, I had gateway 1, gateway 2, and gateway 3. In circular, gateway 1 would be used first, then the second call goes to gateway 2, the third call goes to gateway 3, the fourth call goes to gateway 1. This was circular. But in top-down, the gateway 1 would always be used. Only if gateway 1 is down or the PSTN sends back a busy or an unallocated number, only then he would go to gateway 2. Otherwise, all calls would go to gateway 1 always, unless gateway 1 is down, or if the PSTN sends back a busy or an unallocated number. Again, that's something that does not happen automatically. You have to go and change a setting in the call manager to tell that do not stop routing on when busy, because by default it is set to true, which basically means that if the PSTN sends a busy or an unallocated number, then it would not be routed to the second gateway. It would just, call would just fail. So you have to go and change that setting, which is not default. You would have to change that to set that to false, so that if the first gateway, which is being used in top-down, if that is down, or if it receives a busy or unallocated, the call would be routed to the second gateway. That is top-down. But in circular, it happens automatically, where it goes to the first one, then the second one, then back to the first one, then the second one, and so on. It can be used for load balancing. Now, we also have priority. within the group also. So for this example, I have group 1, which contains the cube, and group 2 contains 2 gateways. In this case, group 1 is always going to be used. Group 2 would not be used. Again, I would have to go and change the settings to false for stop routing if busy or unallocated. I would have to change that settings from true, which is default, to false. Only then from group 1 it would go to group 2. So we have priorities within the group. So within the group it is circular or top down, depending on what you want. But between groups, it always uses group 1. Always. He would always prefer group 1, and all calls would go to group 1. And if group 1 is down, it goes to group 2. Like I said earlier, you don't really need to create route lists, route groups. You could directly call the gateway in the route pattern. Now, talking about digit manipulation, digit manipulation can be done in many places. It's not just one way of doing it. I could change or transform my calling party or calling number and the called number at the route pattern. Or I could do this at the gateway. Or I could do this at a combination of route list and route group. I could do it at the route group level, which is the details of route list. So 3 places where I could do digit manipulation: route pattern, route list and route group, which is a combination, and the third one would be at the gateway. So 3 places I could do digit manipulation. However, what takes preference? What takes preference? So the gateway takes most preference. So if I do some digit manipulation at the route pattern, and I do some digit manipulation at the route list route group, and I do some digit manipulation at the gateway takes preference. Remember, it's whatever changes you make at the route pattern, that's really not happened. It's not happened yet. So let's say if the call comes in from the phone, let's say he was dialing a local call, 9202-2001. Maybe I was dialing a local call. And the call comes into the route pattern. And in the route pattern, I have made some changes. I have changed the calling number to be maybe an E164 number. And at the gateway, I also made changes to change it to 10 digits instead of E164. What would take preference? Well, the call going out to the PSTN would not see E164. He would see 10 digits because the gateway trumps route list route group and the routeless route group trumps route pattern. So whatever changes you make at the route pattern, that's really not occurred at this point of time. He is keeping a note of that okay, this is the changes that I need to do, but he has not made those changes yet. The changes happens later. So if I don't do anything at the gateway or the routeless route group, and I only have at the route pattern, yes, the changes would happen, but not till it reaches the gateway. So even though I have made the configuration changes, I've done the transformation or the manipulation of the calling and the called at the route pattern, it does not make the change at that point of time. It goes to routeless and route group, sees there's no changes there. It goes to gateway, there's no changes there. So then the route pattern changes take effect, and that's what is sent out to the PSTN. So remember that whatever you do at the route pattern or the routeless or the gateway takes preference over the digit manipulation. The gateway always takes preference over the routeless route group, and the routeless route group trumps over route pattern. Remember, it's not an addition, so it's not like, let's say, if I was dialing again a local number 9202-2001, and I go to the route pattern and I say prefix 408, and then I go to the route group and I say prefix 4408, and then I go to the gateway and I say change it to E164. It does not mean that the final call going out to the PSTN, the called number or the calling number would be 408, and then, or in fact, it would be E164 plus 1408, 4408, and then 408. It's not an addition. It's either the route pattern or the routeless route group or the gateway. But gateway takes preference. The final output would be that if you make changes in all three, the gateway would make that final change based on whatever is coming in from the phone. So if the phone is dialing 202-2001, the gateway would change that to E164 and ignore whatever changes you made in the routeless and route group, or ignore whatever changes you made in the route pattern. However, you could still use both if you want. Like, for example, I could do a digit manipulation for the calling number at the route pattern and maybe make changes to the called number at the gateway. In that case, let's say if the phone whose extension is 2001 and he is dialing a local call to the PSTN, which is, let's say, 515-1111. So he dials 9-515-1111. The call comes into the route pattern based on his CSS and partitions, whatever the phone has access to. Assuming the phone has access to a route pattern, the route pattern changes the calling number from 2001 to maybe 7 digits, 202-2001. He does not change the called number. At the routeless route group, I don't make any changes. At the gateway, I only make changes to the called number. I change the called number from 9-515-1111. I strip off the 9 and send just 515-1111. In that case, what goes to the SIP IDSP or the PSTN would be the calling would be 7 digits, 202-2001, which was changed by the route pattern, and the called would be 515-1111, which was changed by the gateway. So you can use a combination, but for the same thing, like calling, I cannot make changes to route pattern and gateway because gateway would take preference. Again, here's an example of class of service. So a phone would normally have calling cert spaces assigned to the device or the line. So normally you would have an internal CSS which has access to the internal partitions. The internal partitions would have all the local DNs, the voicemail, the media ports, the resources, 911 route patterns. I mean, 911 is not kind of internal, but you will still want everyone to have access to 911. The only reason we create multiple CSS is, think about from an organization perspective. You do not want your lobby to be able to make international calls. You don't want somebody, your employees, going out to the lobby and making international calls. So you would want to restrict that. So your lobby or the elevator, the phone in the elevator, you would not want them to have access to dial local calls, because that would incur cost to the company. So you would not give them access, the phones in the lobby or the phones in the elevator. You would not want to give them access to make local calls or international calls. They only have access to dial internally or 911. You would want to give them 911 because, let's say if somebody was having a heart attack and or maybe he was bitten by a shark in the lobby, whatever the reason could be, he needs to dial 911. You would need to give him access to that. So something that you would normally do, you could have a separate CSS and a partition for 911, maybe name it as emergency and have that, but you could just assign that to internal. So you would have at least 3 CSS created for phone access. One would be internal, where certain phones like lobby, elevator, they would only have the CSS internal, which only has the partition internal. Some phones would be given local access, so the local CSS would have access to the internal partition, so they can still dial internally, and they can dial 911, and they could make local calls. Some phones, like maybe your CEO of the company or somebody who needs to constantly dial international, they would have the unrestricted CSS, which has access to the partition internal, local, or even long distance, and international also. So one thing, if you see that there's also something called as CSS none. CSS none is something that we don't create. It is there by default. All phones, all devices belong to CSS none by default. And the CSS none contains the partition none by default. You don't want to keep your devices or your lines or your route patterns in the none partition, because there's no way of actually restricting who can dial what route patterns or what DNs, which is basically in the none partition. You really cannot control that. So you would not want to keep most of your things in none. Do not keep them in none. Maybe create a separate partition for what you desire. So here is an example of a traditional class of service construct. This is also an example of a traditional way or traditional dial plan configuration. So this would be a traditional way of actually doing the stuff. Like back in the days, this is how you would do. So let's say I have some Seattle phones and there are 2 class of services created. Maybe 2 calling search spaces created. I have Seattle restricted and Seattle unrestricted. The Seattle restricted has 911 and has 9.911. And it also has access to the internal DN. So the CSS Seattle restricted has 2 partitions. One is the Seattle 911 and one is the internal. So all they can dial is 911 or 9.911, where 9 is your access code, or they could dial internal DNs. Based on that, they would be using a specific route list, route patterns, and route groups and go out through the Seattle gateway. The Seattle unrestricted has access to 911 partition, has access to the local calls, which is 9 open and close square brackets 2-9 XX, and then 9.1, which is for national call, and then 9.011 bang and 9.011 hash or bang hash. So the Seattle unrestricted has access to 911, local, national, international, and also internal DNs. Again, if you remember, it is actually the calling search spaces and the partitions which basically determine what gateway you are actually going to be using. Because if I keep all of them in none, if I keep all my route patterns in none, everybody has access to that, right? And I don't really know which gateway I'm going to be using. There could be a possibility where somebody in Austin could use the Seattle gateway. You don't really want that. So if the phone has a certain CSS, which has a certain partition, and that partition is assigned to a certain route pattern, and that route pattern calls for the route list or the route group or the gateway, in that case, Seattle would only use the Seattle gateway. Now, if I have Austin, another site, for Austin, I would again have two calling search spaces. One is for restricted and one is for unrestricted. Again, if you notice, back in the old days, the traditional way of doing the dial plan was we would replicate all my route patterns, all my partitions. I would replicate that for every site. So for Austin, I would again have a 911. I would again have 9.911. I would again have local, national, international. The only difference is that it would be in a different partition. So this is the old way of doing your traditional dial plan, which is kind of non-scalable, because imagine the amount of you're calling search spaces, CSS I need to create, and the amount of partitions I need to create, and I'm replicating my route patterns for the same thing. A better way of doing it would be, maybe I have just one set of route patterns which multiple sites could use, but the traditional way was I have to replicate it for every site. So if I have, let's say, 1,000 sites, you know how many calling search spaces we would need and how many partitions we would need. So if I have 1,000 sites, it becomes number of sites times the classes of service. So here I have two classes. I have restricted and unrestricted, right? I have two classes. And if I have 1,000 sites, I would need to do 1,000 times 2, which means 2,000 calling search spaces and 2,000 partitions would need to be created. And imagine the replication of route patterns that I would need in the traditional dial plan implementation, which nowadays nobody uses that. But back in the day, we did use the traditional way of actually implementing the dial plan. But nowadays, nobody uses this method. But it's important for you to know, what did the traditional dial plan look like? So the Seattle had two class of service, so two CSS, and that had 2 or 3 partitions: internal, your PSTN, and 911. Your Austin also had 3 partitions, which was 911, under the PSTN, and internal. And they all had their own route patterns which point to their own gateways. Again, another example or another use case for CSS and partitions would be to avoid toll fraud. You really don't want toll fraud to happen, because that incurs a cost on the organization. For example, I could use CSS and partitions for something like, to avoid toll fraud. What I could do is, let's say if I had not done any restriction, I had not done any partitions, or everything was in PT none. Let's say if I'm an employee and I want to call somebody in, let's say I sit in Seattle, and I need to call somebody in India, and I don't want to make that international call from my personal phone. So what I could do is I could go to my company phone and forward my call to the India phone, and then go back home and make a local call to my company phone, my DN, make a local call there, and that phone redirects or forwards to international to India, and the company pays for the international call. So that's basically toll fraud. You really don't want something like this. So maybe I could have partitions and calling cert spaces created where the phone has access to make international calls. So the phone CSS has access to the partition to make international calls, but the phone CSS, but for forwarding, the phone does not have access to the partition international. So if he forwards the call would not be routed to international because he does not have access to that. So again, this could be a use case for calling cert spaces and partitions. Hello and welcome to INE. Today in this video, we will look at dial pairs. So in this section, we would mainly talk about the call legs. We would talk about the different call legs, inbound call legs, outbound call legs. We would talk about inbound dial pair matching, outbound dial pair matching, equal cost paths, backup paths, and show and debug commands. So there's always two call legs to every gateway. Every time, anytime you make a call, there's always two call legs. There's an inbound call leg and there is an outbound call leg. Typically from call leg perspective or from a gateway perspective, you could have an iOS voice gateway, you could have Cube or CME would also be a gateway, or even call manager. Call managers are also gateways. So looking at this diagram, we have a WAN call where OGW's perspective of leg, where OGW, if you look at this diagram, I have OGW and I have TGW, where OGW is the originating and TGW is the target gateway. So from an OGW perspective, if I have a call coming in from a phone, maybe this phone is the extension 2001, maybe it's a POTS call, maybe this gateway is a CME. So the phone is directly attached to the gateway. So there would be an inbound call leg. Obviously, this inbound call leg would be a POTS call leg. But if there was a SIP phone, there would be a VoIP dial pair and there would be a VoIP inbound call leg. So I have a dial pair voice 20,001 POTS where the destination pattern is 1001. And the port is 50/0/1, which is my skinny phone, which is registered to my CME. So my inbound call leg would be from the phone to the gateway. The next thing would be the outbound call leg, which is going to be, if it's a WAN call, it's going to be a VoIP dial pair, where I have a destination pattern to ... The preference is set to 0. The session target is IPv4 2.2.2.2. Again, you need to ensure that your session target IP address is reachable. It could be reachable through a static route or some kind of routing protocol or maybe BGP. As long as it is reachable, you would be able to make that call. Sometimes you may also see that the session target is a DNS. So you could probably have session target set as DNS. However, you do need to have a name for that case. In fact, a lot of new deployments or in current deployments, you would see that people normally use DNS, but you need to ensure that you can resolve that FQDN. So my inbound call leg is from the phone to the gateway. My outbound call leg is from my gateway towards the WAN side, towards the target gateway. From the WAN call perspective, again, from TGW's perspective, the call leg, the inbound call leg would be the VoIP dial pair. So I have a dial pair VoIP, which has the incoming call number as dot, DTMF relay, but the outbound dial pair here is going to be again POTS if I had a skinny phone attached to that gateway. Again, if I had a SIP phone, my outbound dial pair would be a VoIP dial pair. From the PSTN perspective, let's say if I was making a call and it was going through the PSTN, again, my inbound dial pair, if I had a skinny phone attached to my CME, then my inbound dial pair would be POTS. My outbound dial pair would also be POTS. Again, here I have, for my outbound dial pair, I have a dial pair which is of type POTS. Destination pattern is 2 ... and preference is set to 1. The port has to be defined if it's a POTS dial pair. For VoIP, there's no port, so I don't need to define port, but for POTS, I do need to define port. As far as the lab exam is concerned, you would not be for PSTN call through by creating a dial pair of type POTS. You would not be tested for that. It's only going to be connecting to the PSTN, which is going to be a SIP IDSP. Again, from TGW's perspective of call leg, your inbound dial pair would be a POTS dial pair, and your outbound would also be a POTS if your phone was skinny. So let's look at how does the gateway match, how does the iOS behave, and how does it match the dial pairs. So if the dial pair is of type VoIP or digital TDM, when I say digital TDM, it's not FXS or FXO. It mainly refers to E1 CAS or T1 CAS or T1E1 PRI. So if it is of type VoIP or digital TDM, it will always first look for incoming call number. That's the preference list. First is incoming call number. The incoming call number matches call lead number, which is the DNS. It always matches based on that. If there is no incoming call number, it looks for answer address. The answer address, though it looks like call lead, but it actually matches the calling number, which is the ANI. It matches that. If answer address is not configured, it would try to match destination pattern. Now, usually destination pattern always matches outgoing, but destination pattern can also be used to match incoming, which basically matches the incoming calling number, the ANI. If you're matching destination pattern for an incoming call leg, then it matches the calling number. But if you're using the destination pattern for outbound call leg, it matches the call lead number. Again, you don't really need to have all of them. You could have two call legs. Maybe your incoming call leg would be, you could match based on the incoming call lead number, and the outgoing could be based on destination number. However, you could use the destination number for both, for incoming and outgoing. So I could have one dial pair with no incoming call number, just the destination pattern. In that case, the destination pattern, the same dial pair would be used for incoming calling number, and the same dial pair would be used for outgoing call leg. If the destination pattern is not set, then there would be port as the preference. Again, port is only for PRI, so matches port, but only for POTS calls. And lastly, we have the default dial pair for VoIP calls. Again, the default dial pair is only going to be matched if you have no incoming call number, there's no match in the incoming call number, there's no match in the answer address, there's no match in the destination pattern, or there's no match in the port. Now, for outbound dial pairs, it's pretty straightforward. For outbound dial, the only thing that we have for matching is going to be destination pattern, which matches the call lead number, basically the DNS. So again, coming back to, if you remember, I told you earlier that we had two call legs. Every gateway has two call legs. You must ensure that you always match on the incoming and the outgoing. So for the incoming call leg, you should match something. You don't want to match the default dial pair. So maybe most of the times you would normally use the incoming call lead number to match the incoming call leg, and to match the outgoing call leg, it's going to be destination pattern. Now, default dial pair is bad. Now, why is the default dial pair bad? There are lots of reasons why you should never match the default dial pair. You should always explicitly configure a matching inbound dial pair. There are reasons for that. Because the default dial pair uses any codec. There's no specific codec that you can define. It uses any codec. Again, there's no DTMF relay, which means that DTMF would not work if you were calling Unity Express or Unity Connection or UCCX. You would not have DTMF. DTMF would be broken. Again, DHCP is set to 0, which is the default, which means best effort. There's no DHCP in the default dial pair. VAD is enabled, VAD is bad. No RSVP, which means no call admission control. No TCL or VXML applications, so you cannot trigger any VXML applications, and no TID. That's why whenever you configure dial pairs, always think about which dial pair is going to match. You should always match explicitly a dial pair on the incoming by using maybe an incoming call number or the answer address or destination pattern, or in fact the port if it is PRI or if it's a POTS call. As far as outgoing, you can use destination pattern, but never use the default dial pair. Then we have the direct inward dial, DID, versus two-stage dialing. In two-stage dialing, the call comes into the gateway. The caller hears a second dial tone. They must then dial to match an internal pattern. So if you're a user who's making a call, and if you hear the second dial tone, if you're not tech savvy, you would probably hang up the call because you wouldn't really know what to do. But if you were tech savvy, you would probably know, okay, I have a second dial tone and I will dial the actual internal pattern. This could probably be used for toll fraud. Two-stage dialing is something that you really don't want. You should never use it because it could cause possible toll fraud. Direct inward dial is something that you should configure. The call comes into the gateway. The DNS is passed on to digit analysis immediately. DID is automatic for VoIP dial pairs. It is not automatic for POTS, so you have to configure direct inward dial command on your incoming call leg. Basically, your dial pair, which is for the incoming. DID for POTS is only supported on CAS, ISDN, PRI, BRI, and a special type of card, which is FXS DID. It is not supported for analog ENM or FXO and FXS. So dial pair matching in iOS uses basically regex. It uses regex to actually match a specific dial pair. Because when we give the incoming call number, we actually give regex characters to match that. Maybe let's say if I give destination pattern as 2 ... what is exactly that? That's basically using some kind of regex. So there are different ways of actually doing dial pair matching. We have 0 to 9, which matches a single digit between 0 through 9. We could also use A, B, C, D, which is they're all DTMF characters. So we could use A through D, star and hash, which matches any of those characters. A dot, which is a wildcard that matches any single digit. Plus can be used in different ways. If the plus is put at the front of the string, then it is used to indicate plus E164 dialing. If the plus is not in the start of the string and it's somewhere, anywhere in the middle, then this basically regex means that match one or more of the previous character if it is not first. For example, let's say if I give something like dot plus, it basically means that match the dot, which is any single digit, and the plus would mean that there has to be one character of the previous or more, which means, let's say if I actually dial, excuse me, if I actually dial, let's say 9, and my pattern is dot plus, it basically means that it cannot just be 9, because 9 is matching the dot. The plus means what? It means 1 or more. It's not 0. It means 1 or more, which means I have to dial 99 or 99999. So 1 or more. So at minimum, it would be 2 characters. So 9 and 9. So dot plus means one single digit of the dot, and plus means one of the previous digit or more. So at minimum, there would be 2 characters. The question mark is that this regex basically means 0 or 1 of the previous character. So again, if I use dot question mark, it means that I could have something, I could have no strings. Let's say if I was matching a calling number which had no any, I could use a dot question mark, which means that I could receive a call coming in with no any set, and it would match no characters, or it could match even 1. So if I use dot question marks, and let's say if I was dialing 9, just 9, that would match. Or if there were no strings, that would match. So dot question mark basically means dot is for 1 character. The question mark means there could be no characters in the previous, so 0 or 1. So it would match 9. It would match no characters also. Again, giving question mark on an iOS is kind of different, because sometimes when you give the question mark, it actually gives you an option with additional commands. You really cannot give question mark as a regex. So if you do want to give the question mark, you have to first do Control V and then do question mark if you want to use question mark as a regex. Percentage, this regex means 0 or more of the previous character. Again, if I use dot percentage, it basically means 0 previous characters or more. The difference here with the question mark is that the question mark meant 0 or 1. Where the percentage means 0 or more of the previous character. Caret means beginning of the line. So let's say if I wanted that a specific dial pair needs to be matched if the called or the calling number begins with 408. So I could give a caret 408, which means that any string that begins with 408 would match. The $sign means the end of the line. The T is wait for interdigit timeout. So again, the T could be used in multiple combinations. So let's say if I use a .T, it means any series of digits. It's not just 1 digit. It means that, because normally the dot means 1 digit, but if I use .T, it becomes, okay, you have 1 character, you could have more characters. I would keep waiting for the interdigit timeout. Once the timeout expires, only then I would route the call or send the call ahead. The backslash is the escape. It basically means escape next character to use as literal character. The square brackets is basically for range of digits. So in the square brackets, I could use something like 0-9, which basically means 0 through 9, any single digit from 0 through 9, not multiple digits, just one digit. Or I could use something like 1, 2, 3, which means either 1 or 2 or 3. Or I could even use something like 1, 2, 5, which means either 1 or 2 or 5. Then I have the parentheses, your open and close parentheses. It's a collected pattern of digits normally used with a regex. So again, here I could have something like, in the parentheses, I could have something like, let's say 408. It basically means that all three characters 408 must be present. If I use something like, in the parentheses, I give 408 and then I give question mark at the end, it basically means what? Question mark means 0 or one of the previous characters. So it basically means that 408 may be present or 408 may not be present. I in fact have some examples to show you some dial pair matchings. So here are some examples. So the incoming call number dot, this command matches every incoming call. Destination pattern dot T, this matches every outgoing call to any DNS or incoming from any phone or incoming caller calling number, but with interdigit timeout. Destination pattern plus 1408, 202, 2001. This matches specific plus E164 number. If you remember, the plus at the start indicates E1 plus E164 dialing. Destination pattern 408 in the parentheses and then question mark 515, 1111. This matches outbound DNS or inbound ANI to and from either 408, 515, 1111 or just 515, 1111. If you remember, the question mark was what? 0 or more of the previous character. So I could have 408, 515, 1111, or I could have without the 408, just 515, 1111. Destination pattern caret 408, 515, 1 ... indicates matches outbound DNS or inbound ANI to and from 408, 515, 1, and then any 3 digits, entire range of 1000. However, the pattern must begin with 408, 515, 1, and then have only 3 more digits. Because I have the $sign, it actually ends the string, which means the minute I dial 3 more digits after 408, 515, 1, I dial any 3 digits, it routes the call. And then I have destination pattern 408, 202, 2, and then open and close square bracket 01, ... What does this mean? It matches outbound DNS or the inbound ANI to and from 408, 202, 2, and then 0 or 1, and then any 2 digits. So you see, we could use any of these regex parameters to match incoming call leg or the outgoing call leg. Basically, the whole idea of this is to ensure that we never use the default dial pair. That's why you would know, like I said, you always have 2 call legs. You should always match an incoming dial pair and you should have an outgoing dial pair. Again, I could use the same dial pair for both incoming and outgoing. As long as a dial pair matches, which is not the default dial pair for incoming, you would not have an issue because default dial pair is bad. You should never use that. Here is an example of call routing paths, basically equal paths, load balancing. So I have a phone 1001, which maybe connects to a CME. Maybe the phone is directly connected to the phone. Again, it doesn't really matter. I mean, it could be a call manager, but I have two dial pairs. I have dial pair voice 100, which is of type VoIP, and I have a dial pair voice 101, which is also of type VoIP. My destination pattern in both my dial pairs is 2 ... The preference in both the dial pairs is set to 0, which means the preference is same. Again, lower is better. The lowest is 0. Lower is better. Since the preference is same, how would my iOS gateway behave from perspective of call routing? Well, he would do a load balancing. Let's see why. Again, I have session protocol set to SIP. My session target is IPv4 to 10.10.10.10, and the second dial pair has 10.10.10.20, and I have DTMF relay set. Now, in this case, once the gateway gets the inbound call or the call coming in, it matches the inbound dial pair. For the outbound dial pair, which is the VoIP dial pair, he has two dial pairs which are matching exactly the same. How does the router behave? Well, the router is going to load balance. I mean, the first call would probably go using the first dial pair, which is 100, and the second call would probably go through the second dial pair, which is 101. Again, there's no guarantee that he would use the second dial pair. He may use again the first dial pair because it's actually random. Let me in fact show you that. If I go to any of my router and give the command dial pair hunt and do a question mark, you would see that I have various options for dial pair hunting, and the default is 0, which basically says use the longest match as the first choice to match a dial pair. If that is same, then use the explicit preference. If that is same, then do random selection. Now, in our case, we have preference 0 and my longest match is also the same. Both the dial pairs have 2 ... which means my length is same. My preference is also the same. So then it would do a random selection. However, let's say if dial pair 101 had the destination pattern set as 2001 and my dial pair 100 had 2 ... In that case, he would use dial pair 101 because longest match. Longest match is always number 1. In fact, if you go, let me in fact do a show dial pair. Let's do a show dial pair summary. And if you scroll back up, you would see here that the default dial pair hunt is set to 0. What does 0 mean? It means that use the longest match for selecting your dial pair. If that is the same, use explicit preference. If that is the same, do a random selection. So there's no actual guarantee that he would use for the first call 100, then the second call 101, then the third call 100, then the fourth call 101. There's no specific guarantee. He would just randomly select. Maybe he selects for the first and the second call dial pair 100, and for the third and the fourth call he selects dial pair 101. There's no specific guarantee. However, if I go and change this dial pair hunt to maybe use 3, in that case, he would prefer explicit preference first and then use the longest match in the phone number. So you could change this how you want your dial pair to match. But if you want to do an equal cost, let's say a load balancing, what you could do is ensure that your destination pattern, your outbound call leg, the dial pair in that the destination pattern should be exactly the same, and then the preference should also be the same. In that case, he would do a load balancing. So both my calls would use the WAN to, he's not using the PSTN because I don't have a pod style here, but he would use the WAN to route the call. The only difference is that he is going to use the first dial pair to route the call through the WAN, and then he would use the second dial pair to route the call through the WAN again. If you want to use a backup, let's say if I want to use the PSTN as a backup, if my WAN fails, then I want to use the backup as PSTN. In that case, I could configure something like this, where I have a dial pair voice 100, which is a type VoIP, and I have a dial pair voice 200, which is of type POTS. My destination pattern is still the same, is 2 ... in both of them. However, my preference in the VoIP is 0, and my preference in the POTS is set to 1. In this case, what's my default dial pair hunt type? It is 0, which means what? Look at the longest match first, which is the same in both the dial pairs. If that is same, look at the preference. The preference of dial pair 100 is set to 0, so he would use the WAN link to route the call. He would use dial pair 100. But if the WAN link goes down, then only he would use the POTS, which is preference 1. Now, let's say if dial pair 100 was still 2 ... but dial pair 200, I changed that to 2001. Which one would match? So this one is set to 2 ... which is as it is. I just go to dial pair 200 and change my destination pattern to 2001. By default now, he would choose dial pair 200 because longest match is first. However, if I go back and change this to 3, then explicit preference comes before the longest match. In that case, even though dial pair 200 has 2001, but because he has preference 1 and this one has preference 0, he would choose dial pair 100, even though it's not the longest match, because preference comes first if you change your dial pair hunt style to 3. Here are some useful show commands that you should look at. So let's go to the command. So we have the first one, which is show call active voice. This would show you all your active calls. Again, it gives you a lot of information. A better command would be to use the show call active voice compact. That gives you lesser information and relevant information. You can also use the pipe feature. So you can do a show call active voice pipe, include peer ID, which filters to show you inbound and outbound dial pairs. We could also use the show call active voice pipe, include peer, which basically shows you inbound and outbound dial pairs and also shows you the calling and the call-in numbers. We could use the show call active voice pipe include remote, which shows the IP addresses and the ports for both the sides. We could use the debug VoIP dial pair. Now the debug VoIP dial pair, even though the command is a debug VoIP, it still can be used for both, whether it's a POTS dial pair or a VoIP dial pair. So if I give the debug VoIP dial pair, if it's a POTS dial pair matching, you would still see it. And voice IAC syslog is something that you should always give. The advantage of this command is that it actually simplifies the problem. Let's say if you were trying to make a call and it required a transcoder to be invoked, the call would fail, right? But if I give the voice IAC syslog, I would see a message on my console that codec mismatch. So it just simplifies it for you so that you actually know what the problem is in simple language. Then we have the debug VoIP RTP session named event. Again, these are the list of commands which are pretty useful that you can use to troubleshoot when your dial pairs are not matching or your calls are not going through. Hello and welcome to INE. Today in this video, we will look at voice translation rules in our global dial plan course. So the first thing that we will look at is what exactly are we going to be learning in this video. So we will look at configuration structure of the voice translation rules. We will look at the laws of the voice translation rules, the show and the debug commands, and also we will look at live configuration examples. Now, as far as the configuration structure is concerned, the structure mainly consists of three parts. So if you ever dealt with routers where you had to configure QoS, where we had class maps, policy maps, and then we apply policy map to an interface, it was a three-step process. Similarly here, when you want to create voice translation rules, it's basically a three-step process. Step number one is creating a voice translation rule, which is essentially a set. So where in one set we could have as many rules as we want. Now again, that really depends on the iOS platform. If you are using, let's say, a 12.x or 12.4, then the maximum amount of rules that you can have inside a voice translation set would be 15. But if you are using an iOS platform which is 15.x, basically 15.0t train, in that case, the maximum amount of rules that you can have inside your set would be 100. Now, once you create these voice translation rules, they are ineffective if you do not use them. So they need to be called inside a voice translation profile. Now you can call them using the translate command, and you can do translate calling number or call-in number or the redirect or even the callback. The actual syntax, it would be, let's say if you were translating the calling number, the syntax would be translate calling and the voice translation rule number. Finally, the third step would be applying your voice translation profile to maybe a dial pair or a voice port or even a source group, or in fact globally. So it's a three-step process: creating the voice translation rule, calling your voice translation rule inside a voice translation profile, and then applying your voice translation profile to a dial pair. Now your voice translation rule, the name, it's not alphabetic. You basically have to give a number. For example, voice translation rule number 1. So you have to give a number to it. However, with voice translation profile, you can give a name. So what are the basic laws of the voice translation rules? If you look at the voice translation rules, if you worked on Unix serial editor, which is basically called as Unix sed, it's loosely based on that. It basically takes an input matching string and outputs a translated string. So both the matching string and the translated string must be delineated with a //. Now, what does this actually mean, and how is it loosely based on the Unix sed? If you look at the Unix sed, the Unix sed had the opening /, and then we had the matching number, then we had the middle /, and then we had the translated number, and then the ending /. However, if you look at the voice translation rule, we have the matching number is basically delineated with an opening / and an ending / and then we have a space between them, and then we have the translated number, which again is delineated with an opening / and an ending /. All regex rules applies when you create voice translation rules. To define sets, or even a single set or multiple amount of sets, you must use the parenthesis, but you must escape the parenthesis. For example, if you look at the first example here, I have, in my parenthesis, I have 2 ... However, I must escape that. The opening escape has to be before the opening parenthesis, and the ending escape must be again before the ending parenthesis. So in the first example, I have set number 1, which basically calls for 2 ... In the second example, I have 2 sets created where I have the opening delimiter or the delineated string. So I have the /, which is the escape for the first set. So /, and then we have the opening parenthesis, 202, and then we have the ending /, which is basically used to close the set, and then we have the close parenthesis. Again, here I have 2 separate sets being used. However, this set would be irrelevant if you do not have the, if you look at the third example, I have, it starts with basically /, which is basically used to delineate the matching number with the translated number. So if you look at this, it kind of looks kind of messy, because as you keep creating voice translation rules, it could get messy to look at, but it's pretty straightforward. We'll in fact look at some examples also. Now, to call the set to the translated number, use the / and then the set number. For example, I have / 202, and then I have the escape to start my set number 1 inside the parenthesis, and then I have closed the set, and then I have delineated the first matching number with the translated number, and here I have said /1, which basically means that if I receive a calling number or called number or a redirect called or a redirect target, I could translate 202, let's say 202-2001, I could translate that to 2 ... or just 2001. Here are some useful show and debug commands. 2 main commands we would be using for debugs or show commands. The first one is the test voice translation rule, and then the rule number. This is a pretty useful command, and you must know that this command is an exec level command. You cannot give this at the config or the global level. It has to be given at the exec level. And then we have the debug voice translation, which basically would show you which translation rule matches and what's the matching pattern and what does it get translated to. So let's look at some examples here. I have a router here, and we will start creating some voice translation rules. I'll show you some examples, and we'll look at, in fact, a lot of examples how we can use the voice translation rule. It's a pretty powerful tool and pretty much used in every dial pair. So let's start with going to config and creating a voice translation rule. Again, like I said, the voice translation rule tag cannot be a name. It has to be a number. Let's just give a number 10. Here I can create rules. So I can have multiple rules depending on your iOS platform. 15.x and above, you can create up to 100 rules. So let's say rule number 1 And here it's asking me for the matching pattern. And if you notice, it actually tells me that the matching pattern must be within or between the /, which is basically used to differentiate between the matching and the translated number. So my first example, what we could do is, let's say we give something like this. Let's in fact first see what's after this. If I look at this, it says the replacement pattern, which is the translated number. So let's go and give something like 408, 202, and let's open parenthesis and do 2 ... close the parenthesis and / again to differentiate between the matching and the translated number. And let's give something like //. Now, do you think this is going to work? Let's try this out. Now, the worst part is that it accepts it. If you notice, I did not do an escape. If you remember the rules, whenever you use parenthesis, there must be an escape before that. So I did not do that. What does this mean? The worst part is that the syslog does not really bark at you saying that this is a wrong rule. It's not going to match anything. It does not say anything. It just accepts it. That's the worst part. So if I actually do a test, I should use the command do, because this command has to be executed at the exec level. So if you do want to run a command from the config level and run an exec level command, you can give the do command. So do test. Let's do a test voice translation rule number 1. In fact, it's 10. My voice translation rule number was 10. My tag was 10. And then let's give the number as 408, 202, 2001. What do I see? The syntax is wrong. Voice translation rule 10. It says that it does not match with any of the rules. Now, why did it not match? Because I did not give the escape for my parenthesis. Let's in fact go and change that. So I would go back and give the escape before the parenthesis. So escape here, and again escape here, and let's hit enter. Now if you notice, I gave this command rule 1. It actually overrides. Unless I give rule number 2, it won't create the rule number 2. It's not that I have 2 entries now. If you give the same rule number, it actually overrides. Let's do a show run section. Maybe we can do a show run section voice translation. Pipe to voice translation. You would see that the tag number is 10, my rule number 1, and now I have the escape here. It basically overrides. So there's no 2 entries. If you just give the same rule number, it will always override. So going back, and now if I do a test using the command do test voice translation rule, tag number 10, and give the command or give the matching number as 408, 202, 2001, what it does is that it changes the translated number to nothing. Now this is something that can be used, let's say if you wanted to block some number, maybe you could change it to nothing so it doesn't really match any dial pairs. But let's go and change my rule. What I would do is change this to \1, which basically means that I'm calling for set number 1. This is my first set. So I'm calling for the set. If I give it like this and do a test, what this essentially does is that if the original number is 408, 202, 2001, it changes it to 2001. So it eliminates the digits before the set, which is 408, 202 gets eliminated. And now it is replaced with just 2001. Let's try another example. This time what we would do is, let's try using, maybe what we can do is try without anything. Let's try giving something like this. So we give rule number 1, // space //. Now, what does this mean? What am I actually saying here? I am saying that match nothing and don't do anything, which basically means if I do a test to 408.202.2001, if that's the original number, it keeps the number exactly the same. See, there is a difference. In the previous example, when we saw, if you remember, when we saw something like this, when I did something like this, if this number matches, it was replaced because I had something in the matching segment, because I had something here. If this matches, replace it with nothing. So this replaced it with basically nothing. This would basically block my call. But if I change it to nothing, if my matching number is nothing, which basically means that don't match or don't do anything with the matching number. So anything else which is not none, comes in, then that number is kept the same. Again, if I look at my test, the number is kept the same. So it doesn't matter what my number is, even if I have 408.202.20011, it would keep it the same. It doesn't matter how many digits I have, because there's nothing in my matching number. So if you do have something in your matching number, it would translate that to whatever is in the translated segment. But if you don't have anything in the matching number, it keeps the matching number same exactly as it is. Let's try another number. Let's say if I wanted to prefix, maybe it was an international number and I wanted to prefix maybe a +1. So what I could do is maybe I do something like rule number 1 // +1. Now what is this going to do? If I do a test now, do a test to 408.202.2001, if this is my number, it basically prepends a +1 to the original number. Now again, there's a difference. If I had something in my matching number, it would replace. But because I have nothing in my matching number, I gave nothing in my matching number, whatever came from the call manager or your gateway or your SIP ITSP, whether it's the calling or the call lead, whatever number came in, that number would be prefixed with +1. So for example, if I go back and change this to 408.202.2001, in that case, it does not prefix 1. In this case, the 408.202.2001 gets replaced with +1. So be careful when you use the voice translation rule, and you have to really be careful. You must always do a test. Whenever you create a voice translation rule, you must do a test to see if it matches something. Now let's say if I had a requirement which said that I need that when 408.202.2xxx or 2 ... if that's my pattern, matching pattern, if that comes in, I need to not replace it with +1, but maybe prepend +1. How would we do that? See, me doing it just like this, / /+1. In this case, yes, he was prepending +1 because there's no matching criteria in the matching segment. It keeps the matching part exactly as it is and prepends +1. But what if I wanted to prepend +1 only if the calling number or the call lead number is 408.202.2 to ... What if I wanted to do that? If I go and change it to like this would replace it to +1. It would remove 408, 202, 2001 and replace it with +1. I don't want that. In that case, what I could do is do something like +1 and. What this does is it takes the matching number, prepends +1 and keeps the matching number same. So the AND sign basically means that take the matching number, don't replace it, do a +1 before and keep the number same. So my translated number becomes +1 408 202 2001. Again, if you don't want to match a specific 408 pattern, and let's say you wanted to match 10 digits, most national numbers would always be 10 digits. Let's say if you are living in the US, all your national numbers are going to be 10 digits. If you want to match everything, you could probably match something like this, where we could go and giving it like this. Let's say if I go and change this, yes, it does match all 10 digits, but it also matches 11 digits. It also matches 12 digits. For example, if I go and change this to, if I do a test right now, yes, it matches 408 202 2001 and replaces that with +1 408. It also matches, let's say, 972 303 3001. It also matches that and changes that to +1 972 303 3001. The problem is, it also matches, let's say, 44 202 or 208 555 4444. If I try and match this, it matches that too, right? It matches anything. Because my matching pattern is blank, it basically means anything that comes in, add +1 and then keep the matching number same. So what if I wanted to match just the North American plan, numbering plan, and maybe just match national numbers? What I could do is maybe I go and give my rule as / and then a caret sign which says beginning with maybe 10 dots. So 1 2 3 4 1 2 3 4 and then 1 2, and then $ to end that, and then the / which is your separation point between your matching number and your translated number. And let's give your translated number as +1 /. So what does this mean? Let's try and do this. If I do it like this, what is going to happen? If I try the 44 208 555 4444, this does not match because it's more than 10 digits. But if I go and use 10 digits, which is 972 303 3001, it matches the rule. However, it replaces it with +1. So in that case, I would need to go back and add the ampersand or the AND sign here so that I can not replace it completely, but keep my original number the same and change it to prefix +1. And then keep the matching number the same, which means any 10 digit coming in, not 9, not 11, or not more than 10. If it's 10 digits as the calling or the called, then that gets replaced with +1 and then the 10 digits. So let's go and change that to +1 and let's try and test this. If I do a test now, it changes the 972 303 3001 to +1 972.303.3001. Now, you can in fact even do something like, if you don't want to do something like this, what you could do is maybe have it as rule number 1 with just / / and change it to / / with a +1. I think it is rule number 1 / and then add a +1. And what you could do is give the type as national. So most of the times, when you send the call out to the SIP IDSP, or if the call is coming in from the SIP IDSP, if it's a national call, it would be tagged with the numbering type would be national. So if it is national, then keep it as national. So what this essentially does is that if the number is 972.303.3001 and the type is national, let's do, or in fact, we don't have the option of testing this. If I do a test like this, it's not going to match. But if the call did come in with the type as national, let's go back out to exec and do a test voice translation rule number 10 and do the translated number or the number to match is 972.303.3001 and do a question mark. So I do see the type. Unfortunately, in the do command, I don't see the type. So if I do a type, if the type is national, only then it would translate this to +1 972.303.3001. However, let's say if the calling number was an international number, the PSTN or the ISDN would basically set the type to international. So if it is +44, maybe 208.555.4444, and the type is international, it would not match. So it only matches my national type. Any number that has the type as national, it would match that. Let's go back and look at some more examples. So voice translation rule number 10 and rule number 1. Let's try some more examples. This time, what we'll do is, if you live in, let's say in the States, most ISPs, service providers, don't really like the type to be tagged as international. Let's say if the call manager was sending the call to the PSTN and you don't want, the PSTN does not want the type to be international, we could change that also. What we could do is, if the type is international, then change it to maybe unknown. So I could change this to unknown, and in that case, if the type coming in from my call manager for international, let's look at the rule. Again, I would have to exec out. So let's do a test voice translation rule number 10. And if it is +44 208.555.4444, and if the type is international, then keep the number the same, but change the type to unknown, because most providers would not want you to send the type as international, so they would expect you to change that to maybe unknown. You can change your type, also keeping the matching number the same. Let's try another example. This time we would try maybe multiple sets. So let's try with multiple sets. Let's go back to my voice translation rule, tag number 10. So voice translation rule, tag number 10. Rule number 1, let's create some multiple sets. So maybe set number 1, let's say if I do something like backslash, set number 1 would be 4 ... and close my set. Then set number 2 would be 2 ... close my set. And set number 3 would be 2 ... and close my set. And let's say if I give that, if it is something like this, then change it to maybe \1, \2, \3. What do you think this is going to do? This would keep the number the same. So if it is 4 ... then 2 ... and then 2 ... change it, replace it with set number 1, which is 4 ... then set number 2, which is 2 ... and then set number 3, which is 2 ... So for example, if I do a test voice translation rule 10, and if I do 972.303.3001, this would not match. So this would not basically match any of my rule. Let's go and do a test. Exit out and do a test voice translation rule 10 972.303.3001. This basically does not really match anything. Let me check my voice translation rule. It should in fact give you a message that it did not match anything. Let's do a show run section voice translation. So I do have a rule here which says that if it is 400, so again, the reason I didn't actually see anything because I don't have any rule that matches 972. So obviously it doesn't give you any message or a syslog message. But if I actually go back to my voice translation rule tag 10, and let's say I do a rule number 2 / matching and translated number, keep it as same. And if I do a test now, you would see that it does not match rule number 1, it matches rule number 2. Because earlier there was no voice translation rule that matched that specific number, it didn't actually give me anything. But because now I have rule number 2, it does match that and gives me a message that, okay, it matched rule number 2. Let me go back and remove this rule number 2 and let's do a test for 408, 202, 2001. What do you think this is going to happen? This would match rule number 1 and the number was kept the same because I had in the translated number, I had \1, which was set 1, then set 2, then set 3. This is my set 1, this was my set 2, and this was my set 3. Again, I don't really have to do it in the same order. I could go and change this to maybe have it something like, maybe I give this as set 3, \2, \1. In this case, my original number was 408, 202, 2001. This would be replaced with 2001, 202, 408, the reverse order. So this is my set number 1, this is set number 2, and this is set number 3. Same thing, I could do something like Maybe I do something like set 3 to. Now, what does this mean? This is set number 3. The set number 3 has the escape before, but this number 2, this is not set number 2. This is just like a digit 2. So what this essentially does is that 408.202.2001, which is here, this gets replaced with set number 3, and then 2 is added at the end. So if I test this now, I would see 2001, which is my set 3, and then 2 was added at the end. It's not prefix, it's added at the end, where I have 2, and this is what we expected it to be. So these are my voice translation rules. And once you create your voice translation rules, for them to be applied somewhere, you cannot apply your voice translation rules directly to your dial pairs or your voice ports. You cannot apply your voice translation rules. So you need to nest this voice translation rule inside a voice translation profile. So let's create a voice translation profile now, which is done with the command voice translation profile, and here the tag is a name rather than a number. For voice translation rule, it was a number versus a voice translation profile. That's just a name. Let's give this as maybe what we can do is give it as outbound to outbound, if I can spell it right, outbound to SIP IDSP. And here I would use the command translate. I have the option of translating call lead number, or the callback number, or the call link number, or the redirect called versus the redirect target. This basically is used when, let's say, if the redirect has happened or not. So if the redirect has not happened yet, we could match it. We could say redirect target. If the redirect has happened, then we could use the redirect called. Again, let's just try with call lead. So translate call lead, and then my tag, the voice translation rule tag number, which was basically 10. Let me quickly show you the running config. Do show run section voice translation. So here I have my voice translation rule tag number 10, which is basically called inside my voice translation profile, and that translates the call lead number. So if the call lead number is 408 or 4 dot dot 2 dot dot and then 2 dot dot dot, if that's my call lead number, that would be replaced with 2 dot 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 and then 2. Now obviously this has to be applied somewhere. This would be applied on inside my dial pair. I could apply this to my voice ports also, or globally. Let's in fact look at the dial pair. So let's create a dial pair voice, let's say 1. This could be parts, this could be a white dial pair. Let's just create a white dial pair. And here I would say translation profile. It could be incoming, so I could match it based on the incoming call leg. So since my profile contains call lead, so if I give it as incoming, it basically matches if the incoming call lead number is 4 dot dot 2 dot dot 2 dot dot dot. Or I can match it on the outgoing. If the outgoing dial pair, if the outgoing call lead number is that, it would match that. So let's do it as incoming. So incoming, and then my tag name, which is here. Again, be careful with your voice translation profile tag name. For example, if I go and let's say add another P, the worst part is that the iOS does not bark back at you saying that, hey, this is wrong and it's not going to match. So be careful with this. because this would not match anything. It would not change anything because I don't have a voice translation profile with this name. So be careful with your naming conventions and always do a copy paste whenever you apply your translation profile to your dial pairs. Now again, coming back to the two methods of testing, if you remember, one was I could use the test command, which we just did many times. We use the test voice translation rule to identify which dial pair or which, what would be my translated number once it matches, which rule matches, and how would it translate that. I could use the test command. Another way to test this could be, obviously I can test this by making an inbound call from the SIP ITSP. I could test this and the dial pair should match, it should translate, and the calling or the call-in number should change to 2 ... and then 2. But there's another way to actually test this. We could do a debug voice translation. So we could do a debug voice translation, and once we do a debug, if I make a call from the SIP ITSP inbound, it matches the dial pair, it should trigger and tell me what's the matching pattern and what's the translated pattern. However, I'm not going to make a call, but we could test this with the test command. My debug should trigger and tell me what's the matching pattern and what's the translated pattern. Let's do a test voice translation rule number 10 or tag number 10. It's not rule number, it's the tag number. And then let's do 408.202.2001. Once I give this command, it should show me that, okay, so if you see here, I have the serial editor substitute, which says that it was a successful match. So the pattern was 408.202.2001. It matched the string that I had given in my translation rule, 4 ... 2 ... and 2 ... Notice it does not show the escape, and it does not show the forward slash. It does not show that, and it replaced that with the string that I had given in my voice translation rule, which was \32. 3 was my set, 2 was just a digit, and it replaced it with the pattern 2001-2. So you see, with the debug voice translation command, we could actually look at what's the matching pattern and what's the voice translation rule string that we have defined and what it replaces it to, and what's the translated pattern in my voice translation rule.